Dear students, from the topic integration, today we are going to discuss the integration by parts. Already we have discussed the theorem, that is integration u into v dx is equal to u into integration v dx minus integration into derivative of u with respect to x into integration of v dx with respect to x. So this is the rule which is useful to find out the integration of the function which is given in the form of product of two functions. Now today we are going to discuss the type number 4, that is substitution, and then we have to use the integration by parts. Already we have completed the type number 1, type number 2 and type number 3. So let us see. Now here this is the type number 4, that is the substitution and using by parts rule. So from your topic there is a exercise number 3.3 in which the question number 13, 14, 15, 16, 18 and 21 are related to this type number 4. So today we will solve some of them by using the substitution and then by using by parts rule. So let us see now. Now see here, question number 13, integration of log x upon x. Now to solve this integration, first of all, if you observe this carefully, then there is a log function log x and other one is 1 upon x. So there is a relation between log x and 1 upon x, that derivative of log x is 1 upon x. So first of all, if you write the integration I is equal to log of log x upon x, then first of all we have to use the substitution method. So here I will put log x is equal to t. Then what will you get? That implies 1 upon x dx is equal to dt. Now by this substitution we get the integration, that is log of, now log x means t, into 1 upon x dx means dt. So the given integration is converted after the substitution, it is converted into log t into dt. Now to integrate log of t, as we know that we have to integrate this by using by parts rule. So we have to take log t into 1 as a second function. So as earlier we have discussed this type also, that considering 1 as another function. Already we have discussed this in type number 2, remember. Okay, so further you have to, after considering 1 as a second function, so this is u and this is v, now evaluate by using integration by parts. So log t as it is into integration of 1 dt minus integration into derivative, now here it is with respect to t, of log t into integration of 1 dt. So remember here we have to evaluate with respect to t. So this is by using integration by parts. Now complete this. Now integration of 1 with respect to t is t. So it is t into log t into log t minus integration, now in this bracket derivative of log t is 1 upon t into integration of 1 is t with respect to t. Okay, so next step, what will you get here? T into log t as it is minus integration of 1 upon t into t is 1 with respect to t. We have to evaluate the integration of 1 with respect to t, and hence we get t into log t minus integration of 1 is t. So integration is completed, so you have to write the constant here. Now resubstitute, because this is the substitution method, so we will resubstitute the t is equal to log x. So this is log x into log of log x minus, here it is log x plus constant. So here we use the by parts rule, but first of all we have to use the substitution method here, and then after substitution we have to use the integration by parts rule. So this is the type number 4 that we are going to discuss today. Okay, so remember this very important example. Now another example, question number 14, that is evaluate the integration t into sine inverse t upon root of 1 minus t square dt. So in answer, first of all I will write the given integration. I is equal to t into sine inverse of t upon root of 1 minus t square dt. Now if you observe here, then there is a sine inverse function, and we know that derivative of sine inverse x is, see here, derivative of sine inverse x, all of you know that it is equal to 1 upon root of 1 minus x square. So there is a relation between sine inverse of t, and here it is 1 upon root of 1 minus t square. So before evaluating this, we have to substitute, put sine inverse of t is equal to, now we will consider here variable x. So consider sine inverse t is equal to x. So that's why 1 upon root of 1 minus t square dt is equal to dx. Okay, so this is the substitution. Now here we have to substitute the value of sine inverse of t is equal to x, and 1 upon root of 1 minus t square dt is equal to dx. But the remaining part is t. We have to substitute t also. Now as sine inverse of t is equal to x, then what is the value of t? T will be sine x. So as per the given, we will replace the terms here. So the given integration becomes, now in place of t we have to put sine x, and in place of sine inverse t I will put x into dx. Dx is in place of 1 upon root of 1 minus t square dt. So let us see here the conversion carefully. Okay, now we are, if you observe here, then it is sine x into x. So we get the function in the form of product of two functions. So that's why the integration by parts rule is applicable. Okay, now by LIATE rule, we have to put x first and then sine x as a second function. Okay, so after substitution we have to use the integration by parts. So I will write it is x into sine x dx. Now apply the rule, that is integration by parts. So x as it is into integration of sine x minus integration into bracket derivative of x into integration of sine x dx with respect to x. So see this carefully. So x as it is into integration of sine x is, all of you know that it is minus cos x. So minus of x cos x, I will write here minus of x cos x minus integration. Now derivative of x is 1. So in bracket here you will get 1 into integration of sine x is minus cos x. Okay, so write in this proper way. Here it is cos x dx. So see in bracket properly, what will you get? Okay, then it is equal to minus x into cos x. Now here it is 1 into minus cos x, that minus minus becomes plus, and into integration we have to evaluate the integration of only cos x, and hence we get minus x into cos x plus, now the integration of cos x is sin x plus constant. Now remember, we have to put the value of x here, resubstitution. Here integration is completed, resubstitute. Here x is equal to sine inverse t. Then what will you get here? Minus x means sine inverse of t, remember, into cos of sine inverse t plus, here it is sine of sine inverse t plus constant. So resubstitution is completed. Again we can write it as minus of sine inverse of t into cos of sine inverse t plus, now sine of sine inverse t means t, and plus constant. So this is our final answer. So again here see that after substitution, first of all we need the substitution here surely, because here it is sine inverse of t function and there is 1 upon root of 1 minus t square, and after the proper substitution that given function converts into sin x into x, that is the product of two function, and to evaluate that we have to use the integration by parts rule. Okay, so that is the that's why it is the type number 4, where first of all we needs the substitution and then we have to use the integration by parts rule. Okay, now next one is question number 15. Here it is integration of cos root x dx. Now if you observe this function, then first of all here we will put, first of all I will write I is equal to integration of cos root x dx. Here we will put root x is equal to t. Then that implies 1 upon 2 root x dx is equal to dt, because the derivative of root x is 1 upon 2 root x, and hence we will write 1 upon 2 root x dx is equal to dt. So now we need the replacement of dx, but here dx is equal to 2 root x dt, but what is root x here? It is 2 into t dt. So in place of root x we will put t, and in place of dx we will put 2t dt. Okay, so again if you observe this function, the conversion is I is equal to, see here, cos of t into 2 times t dt. Okay, now I will rewrite this. 2 you can take outside into, now there are two functions in the form of product, one is cos t and other one is t. Now by LIT rule we have to put t first and then cos t. So after this substitution, after the substitution of root x is equal to t, the original function is converted into the product of two functions. So that's why here we need the integration by parts rule. Okay, so keep t as it is into integration of cos t dt minus integration into bracket derivative of t into integration of cos t dt. Okay, so evaluate by using integration by parts like this. So that is equal to 2 into curly bracket. Now integration of cos t is sin t, so I will write t into sin t minus integration, now in bracket derivative of t is 1 into integration of cos t is sin t into integration of this. Okay, so next 2 into bracket t into sin t minus, now integration here see we have to evaluate the integration of 1 into sin t, but integration of sin t, that is minus cos t, so minus minus becomes plus here, that is cos t, and plus integration constant. Now resubstitute the value of t as root x, so 2 into root x into sin root x plus cos root x plus constant. So here if you observe this function, then it is actually cos root x dx, so directly you put the value of root x is equal to t, and then we get dx is equal to 2 root x dt and then 2t dt, and after that substitution we have to use the integration by parts rule, and hence this is also related to the type number 4. Okay, so you solve some examples from the exercise 3.3 which are related to this type. Okay, thank you.